Tak? Dobra. Okay, so let's start. So, my name is Krzysztof, as I was introduced. And I'll be talking about types today. But first, a few things about myself. I work in a company called Polydia, which is this nice logo. And I also organize, or co-organize, let's say, a meetup called Mobile Warsaw, which is very similar to this. Yes?
Can you talk a little bit louder?
Even louder? Okay. How come? Even louder. Sure. So I'm organizing those meetups, and also I work at Polydia. And one thing I would like to just state at the very beginning: if anything is not obvious, or anything is unclear, or you cannot understand some part, just ask the question directly. Raise your hand. I will give you the time to ask the question. This talk was born out of the practical challenges of dealing with the recent API that I was working with in a project I was doing. So this is like a very practical talk. So I would really like you to understand what's going on. Just raise your hand if anything is not understandable. So I will be talking about types, but not all the types tonight. The types I will be talking to will be some particular kind of types. But let's start first with asking ourselves, why do we use types at all? So types are pretty okay, and Swift is really heavily using them. They are giving us a structure. I mean, basically, a type system is just like a system, right? So this is something that you can upload some of your assumptions, some of your logic, some of relationships in your app to the system, the type system. So basically, if you just encode it into types, you just get like something like a little bit similar to the unit test structure, but done during the compilation. Other nice thing about types that are just a nice way of documenting your code and sending messages to other programmers. I mean, this is not like the only thing that you can do or should do or might do, but using types in a nice way can really express a lot of thought that's going behind this particular logic that you're implementing. And also, we can use types to clarify a lot of things in terms of like some common patterns that we use. We'll see a number of examples in a moment. The types that I'll be talking today, that I'm especially interested in, are the ones that I call container types, and they are not like the container types in terms like the containers from the standard library, like sequences or dictionaries. It's about the types that do encapsulate some logic and then store and carry some value inside them. So basically, they are like boxes, but not like dumb boxes. They are also providing some additional meaning. Let's see the example. The most well-known container type of all, optional. So optional is just providing one simple meaning. There is a value or there is non-value. So there is either 0 or 1 value in the container, right? And the optional is actually storing this value under the hood. So that's why it's the container. Array, it's very similar. It's just encapsulating some other concept. There might be 0, 1, or a lot, or many values. So, of course, array is also storing the values. And it just gives the meaning that there might be many, many, many values in this particular part of your application. Then, a little bit less known, but still pretty widely used, result. So result is a container that is a little bit similar to optional. It can also carry one single value, but there is no possibility for it to not carry any data, like an optional. It always carries some data. It's just that if there is no value, there is an error. So it's used to express that there might be some errors when you are receiving the values, computing the values, and so on. By the way, you might be wondering about this part if you've been using error results before, because there is like this great debate among people who are using results in Swift, whether we should generalize them only on the data or on the data and an error. So just quick survey. please raise your hand if you prefer this version with only T. Please raise your hand. Don't be shy. We're all friends here, no one will judge. Okay, only one person, okay. At least from what I saw. That's surprising. So for all the other people here, you will probably only find this like another argument to use this pattern generalized on the both sides. I was in this result T camp for a long time, but I was convinced by this particular talk. This is the one talk that convinced me. It's by a Japanese guy called Yasuhiro Inami, and he did this as a flash talk at Try Swift, and it is pretty convincing argument why the result generalized on both, let's say, variants is actually more expressive. Anyway, if you prefer to use the one without the error, it's cool. I mean, I won't judge. Anyway, back to the types. Another one pretty widely used is also sometimes called future. There's also a variant called promise, which is a little bit like, but a little bit slightly different. I mean, all those types have different variants, right? So this one encapsulates this idea that the value is not available yet. So it might not have been computed yet. Maybe we are just fetching it from somewhere, and it's been done asynchronously. Maybe it's been done on the other thread, so we are not sure when it comes. So this is basically this one container that encapsulates this concept. Well, this is a little bit less used. So there is W here, okay? This is writer. The writer one is just an idea that you want to express the situation when you are doing something with the value, changing it, transforming it, computing, whatever, you might also want to store some side effect. This is like the best well-known example, and the only one that I've been using it for, is to put the log here. So each time you're doing something with the value, you're also generating, for example, like a string with a log, what's been done with the value. But you can do a lot of things here. You can even maybe store some actual side effects like functions or closures that are being just added, and then you don't want to, and you want just one single place that you're just executing them all, okay? So you just want to express that you are doing something, but lazily, and then you are just doing side effects when you are actually being told. So this might be used also for doing things lazily. This one is the one I've been using a lot. It's called observable. If you've been using RX Swift, you're very well familiar with that. If you've been using reactive Cocoa, you are familiar with that as a signal. And in reactive Cocoa, the signal is actually generalized on both error and value. So again, there's a debate here to be had. And the concept is that it stores the concept that there is a number of values, the same as in an array, but they are just distributed in time. So they are not available at the same moment. They are distributed in time. So the sequence of values in time, it might be finite, it might not be finite, it might also error out. So there's like a number of things going on in the observable. It's one of the wider types, let's say, so the ones that can actually show a lot of meanings to the other programmer. And this is also why I think of observables as like the most dynamic of the container types that I usually use. Okay, so we know what we are talking about right now. We are talking about those kind of types, right? So why should we use that? Why should we use that? I mean, Cocoa is not using it. Apple is not using it. All the system APIs are not using it. So basically, if we are like not calling completion handlers, but we're using futures, we do need to write all this boilerplate, this adapter code that just joins this Apple world with our world, and then we want to maintain that, and the more code, the worse. So why should we do that? What do we gain? We gain actually three things. First of all, we gain expressiveness. So as I said, if you are passing somewhere a completion handler, it may mean that there is something done asynchronously in multiple ways. It also may mean some other things. Sometimes the completion handler is just basically like a closure that will be used to store some things. But if we use future, and especially if you use future like in our app in the same situations, you can really express what it means that you want to put into express the logic that you have in your app. So the patterns that you are usually using are more easily visible. Second, we get the common API, which is like awesome, because then all those types, because of these underlying relationships behind them, that is mathematical, and I won't go there because I'm not a mathematician, and also I don't think it's very, it's that much, it's not that needed to use them, especially at the beginning. All those types do provide you usually with similar API, which is awesome, right? I mean, you learn one mental model. One mental model is better than React Native, actually. You learn one, you write all the types. You learn one meaning of a method, and then you're cool. All the types provide the same. And third, we gain chainability, which is pretty awesome because we are working with containers. So something is stored, right? Something is stored inside something other. So we cannot really work on things that are stored that are inside containers. So we only can tell containers, please do this for me. Please do this for me. And you know what? There is this definition of declarative style of programming that is about tell what to do, not how to do. And this is exactly what we cannot avoid using containers. If you use the container, you just can't tell the container how to do things because it's in the container. It's container's thing to do this thing. So you have to be declarative, which is pretty awesome. And with being declarative comes chainability as well. So if everything is that cool and those types are so awesome and everything is like unicorns and rainbows, so why I am standing here and giving a talk about not to go crazy with the container types. Well, because you will, when you start to use them, you will soon notice that it's all awesome as long as your logic is really nicely expressed in this particular type that you're working with. For example, all that you care in this part of your logic is that there is only a value or a lack of a value. But the logic that we write has usually a multiple context, multiple meanings. Let's start with an example. So imagine you've got this feature request, let's say this user story to implement. Your task is to implement that. So there is an app. The app is a GitHub client. Of course, in the GitHub client, we are at the programming meetup. Great Microsoft service, really. So you want to give the ability to the user to see all those repos written in Swift language. So you will probably need to make a request, right? Because GitHub is on the internet, and the internet is done with the request, so request. Basic API that iOS has for networking is done here. We will be, for example, using this method. And the one thing that you can notice immediately is this completion handler. And there's a number of things going on with the completion handler. First, the completion, as we've been talking when we are introducing future, is expressing, it might express that something is done asynchronously, and here it actually is. So we can just wrap it into the future and not really think of the completion handler anymore. But also, there is a possibility of an error here. So we would like to express that there might be a value, but there might also be an error. So we can use result. And also, the funny thing is that the value might actually not exist either because of this construction that is brought from Coco, from Objective-C. So the results should actually be used with the optional inside. So what we get is a deferred of a result of a data of a network error, which is like pretty huge number of containers already, like 3 layers down. layer in a layer in a layer. But that's not all. Because what we do with the data, after we get it, we probably don't want to deserialize it. I mean, no one will read those repos in the binary format, right? So imagine there is this method. Here is data, and here is the repo, and you just pass the data and get the number of repos. That would change the signature into something like this. But this method probably may fail, right? I mean, maybe the API has changed. Maybe we have some bug in our data model. So we can actually add another result. So there is the result which has a deserialization error, and now we have the deferred of a result of a result. Okay, 2 errors already, and there's the optional still. But then you might be interested in maybe the whole structure of an API is okay, but maybe some particular part of this object is giving you some errors. Because, I mean, this is JSON, right? So the schema is like only the document somewhere and we should follow. So we can actually think that each one of those objects in this array of repos may also fail or not. So now we have just like a deferred in a result, and inside there's an array of also results that may also fail. So then we're doing validation. Validation may be seen as like a simple repo to bool logic, because we just want to, for example, validate the story was that the repo is written in a Swift language. But validation might be a little bit more complicated, and if there is a number of validations in a wrap, you would probably want to encapsulate somewhere, express somewhere what is the actual result of this failure. So then we have, again, something that is failing. So now we have deferred of a result of an array of a result, and there was an optional. It's going to be a little bit complicated. Presentation fortunately doesn't change anything, only the type, the repo here. Although, first thing, you are probably already wondering how to get to this repo here from all those layers. And also, like, there's a number of types, right? Like, there are so many types. Raise your hand if you like the signature. I was not expecting that, because, I mean, this is madness. How can you work with that? And we got there actually trying to incorporate types into our apps. We're trying to be more expressive. We're trying to put, at each step, think of what shall we pass to other layers? What shall we, like, how all the information should be stored somewhere? And what we got this unmaintainable, unworkable signature. So we need to simplify that, basically. And there are 3 ways that I would like to show. Some of them are totally obvious, some of them maybe will not be, hopefully. First, you can just redesign your model. And by your data model, I mean also your errors, which are part of data model. So result is so popular in this community, not without reason. A lot of things may fail in the apps, right? Especially the apps that we write, mobile apps that are usually either fetching something from the disk or fetching something from the network and then displaying. The display part is usually the one that will fail the least, but the errors on the fetching side have to be maintained somehow. And so we can just take this part into consideration and see that here we have a result inside the result, and we have 2 separate errors. So first thing, we may just think of redesigning that and creating the repo error that expresses both situations, both the problem with the deserialization of the repo and the problem of validation of the repo. It can be composed of the other errors. It can be like the special error just for this case. But either way, it will greatly simplify the signature in this part. And now we are just like 1 layer less inside containers. Then let's look at those parts, okay? So here is the result. Inside the result that has, this result is an optional. So the result of an optional of a result and then the network error. And if you remember, we got this optional here only because the Cocoa API is giving us the possibility of both the error and the value be nil. But we can easily think of this situation as an error as well. Because, I mean, what can we do with this situation? This is basically, even if it's not an error per se, it's still an error for us. I mean, for the presentation layer, definitely is an error. So we can just add some new case that indicates the lack of data, and then, voila, our signature is getting one layer less. It's slimmer, it's getting slimmer, we're getting somewhere. Okay, that was first thing. We can just redesign our data model, especially redesign our errors, for this API at least. Your mileage may vary. The second thing you can do, also pretty obvious, discard information. So when we're building this signature, we thought of all the possible situations, all the possible things that we will want to express for a user. For example, we were having this array of the errors. So for each object in the array in the JSON, we could express whether it failed validation and deserialization or not. It could be very useful in your app. Maybe you just want, maybe your API somehow has those situations where different objects might be in different places. So like there's schemaless in this sense, like the classic sense. For example, I've been working with Firebase. You can very easily get to this point at Firebase. But you can also think of the situations that like half of the repos are decodable and the other half is not as an error as well. So you can just simplify that and think that if there's any error in this array, we'll just treat the whole array as error, okay? So check if there's any error. If there is, it goes here, and if it's not, strings go here. And now we have just transformed the array. It's not longer on the outside, it's in the inside. We've lost some information on the step. But now our signature is a little bit simpler, and also we get one more thing. Now we are in our classic result in a result situation, and what's even better, the errors match. So we can just simply merge them, right? Let me just merge them. So this is already pretty manageable. And we got here by basically just only transforming our errors and discarding a little bit of information. But the most interesting part comes here, because here we still have this result inside result situation, and we could think that, okay, let's merge those errors as well. I don't really think it's a good idea, because this might be very different in the meaning, by which I mean in how do you want to handle them further down the road. For example, the network API error, if there is a possibility of reconnection, of repeated requests, it will be very interesting to have this information. And this is something a little bit different. It's about the structure of the data coming from your server, right? So let's try to work with them directly. And the way to work with them directly is by something called transformers. And transformers are basically just like APIs for working with nested containers. So it's like they were designed exactly for this purpose. They come from Haskell, like everything about types comes from Haskell. And in Haskell they're called monad transformers. And there's actually like a package of monad transformers that you can use in Haskell. I'm not like a Haskell programmer, but that's how I've been just reading, okay? For me, transformers are APIs. So what I would like to write is that I would like to express this logic that when I am having a deferred error object that has a result as a data type, then I'm able to just apply this function, this mapping functions, to the result, to the inner thing. So basically working with the containers, nested containers means a way of getting the function and apply them somewhere deep inside, not on the first layer. Unfortunately, it's not that simple in Swift. Generics and type constraints are not really much in love. And what we get here is an error code that the reference to generic type requires arguments. So this result cannot be just like left here without generic, any generic signature. So how can we try to make it some other way? I wish some of the ways that I tried, so that you know that these are not helpful. You can try to put some random names here, and just hoping that the compiler will understand. It won't. It says that I don't know what this result data is. I mean, yeah, it was not declared somewhere. I also tried to do with type alias. I thought it's really smart, but it's not working either. When you're trying to do it with the type alias, it just says that you cannot really use those things from type alias in the extension. So basically, these are the ways that we cannot do the monad transformers. There are only two ways that I know of that we can. First, it's protocol-based. And I call it RASURE. And it's a joke, because RASURE, I think of it like an inversion of type erasure. So it's just no I here, no E here. So do you know what type erasure is? Are you familiar with the concept? Who is familiar with the concept of type erasure? Like, raise your hand. Okay, so I will just quickly introduce that without any slides. So type erasure is basically when you do have the protocols with associated types, and you want to provide some container, again, for storing the instances, so that you can have them as a field in your classes, for example, as properties. Because you cannot just say that I want a property of protocol with associated types, because it then says that, yeah, but it requires, I mean, it cannot be used here, and it cannot be used here because it doesn't know how big it is, because of those associated types construction. So basically, the classic examples of those are the any types, any collection, for example, any sequence. You might see any optional. You might be ever written also any validator, for example. Anything that is really like having any and then the generic signature that mirrors the one from the protocol is a type erasure pattern. So type erasure is just an inversion of that. So you don't have a protocol, you have a concrete type, but you are creating a protocol. You are creating protocol with associated types. So instead of getting the associated type and putting them into the signature, you're getting the types from the signature and put them into the protocol. Then you duplicate API, so you're basically copying all the signatures to the protocol, and then you constrain those extensions that you want to write, those transformers, with protocols. Okay? Let's see that. You do have a result type. And result, for result, you can just write the protocol. Result type, this is the protocol. The actual type is called result. And result is of T and E, as we've seen. We are just putting the associated types here and linking the associated types and the signatures and the generic signature here. Then you duplicate API. You're just copying all those methods. But important thing is that you can still return the concrete types here, because you are not doing protocol-oriented programming here. You're not like lifting things into the protocol level and working on the protocol level. You just are trying to work with the Swift compiler. So this is the concrete type that you're returning here, the actual concrete result type. Then of course you need to conform to this protocol. And then when you're trying to work the transformer, it works. So basically you can now say that here is the third of T, and you can say that T is a subclass, sorry, it's not a subclass, it implements the result type protocol. Okay? And now you can, because you've linked associated types and generic signature of a result, you can just let's say, use those associated types here in the signature, and everything is okay. And you can use the map function, because map function was duplicated in the protocol. So this works. This is pretty awesome. Although there's one drawback. The drawback is that you need to write those protocols for every one type that you are using, so for optional array and so on. That's why there's also another method that I found. I call it Constrain. And this one is available only recently. I think it's available since Swift 4.1. Because it's about using this new API of actually, let's say, it was developed for the conditional conformance. So let's call it the conditional conformance API that you can just use to say that the generic parameter should be a concrete thing, no longer implement something that implements something else or is something else or something else. Anyway, here you're just repeating the signature of the inner container, so of result in this case, in the generic signature of a method. You're not adding anything to extensions. You're just doing it for the method. Because of that, and because the methods are now constrained with this where clause, you can write the types the usual way, which is pretty awesome. So here you're just writing that this is a basically that's like return the usual result, usual deferred, and you can just say that constraint is here with the actual concrete type. No need for the protocols at all. So the one drawback, I mean, both methods have drawbacks, unfortunately. One drawback is that for each method, you need to write those signatures. So I would really love for the Swift to have this some kind of syntactic sugar that says that you can actually say that deferred were in something like this, and it will just know append those to the method signature and whatever. It's not working like that. Sorry. Anyway, but looking on the bright side, now we can express our logic, our whole logic, our fetching, deserializing, validating, and actual presentation in one chain, which is awesome. We are working with this type. We are working with this type. So here we can just say what to do with the repo, how to present the repo, how to make a string out of repo, just get the name. But we do not have to go through any of those layers anymore, which is pretty awesome. But does it really prevent the headache? Does it really prevent the madness? It definitely moves that madness into some other part of your code. The main problem is that you will need a lot of transformers, because those transformers need to be written for all the combinations of types that you are using, okay? So if you're having deferred with an array, there's another transformer, and optional another transformer, and so on and so forth. And for now, this is not something that you can avoid in Swift. So I'll just present you four recommendations, not even solutions, for how to live with that. First, this is what I do usually. I just stick to what I use. In your API, you're probably not duplicating code, but you are duplicating some patterns, some ideas. If your services are, if half of your services is just fetching the data from let's say, Realm database, and the other half from the network, probably those services have similar structure, okay? Then maybe just few of those transformers, maybe 5, maybe 10 of those transformers is needed to cover all the cases that you have in your app. And this is what I'm doing usually. I then give them some better names, just to for the fellow programmers to know that it's not like the usual map, but some special map that's doing something on the internal containers. And you can manage. Another approach is to generate them. This is like the opposite approach. Instead of like sticking to what you have, generate everything, every combination. How many layers deep? Elvira Roca is a great functional the programmer, he's had this talk called Protocol-Oriented Monad Transformers last year at Functional Swift in Berlin. And he was using sorcery to do the generation. And there is a source code, I think it's linked to the presentation, that he generated all the transformers for the containers inside containers, and then for the containers inside containers inside containers. So up to 3 layers. And there is only this small comment that says that for the 4th layer, it was just so many that it took too much time. So, and not actually generation, the compilation took too much time. So he just skipped that. But yeah, this is also something that you might find useful. Another solution, you can just forget about all these things that we're discussing here, all these problems with nested containers, and just use wide types. This is probably something that a lot of us have been doing. And the widest one, as I said, is an observable. So the observable can express a lot of things. The observable, you can use an observable as a replacement for an optional, because the observable can just, let's say, finish the sequence without returning any value, which you might interpret as nil. It can be used as a future, because it will do something asynchronously. It has an error built in, and if you don't miss this error here in the signature, you can just always use the reactive Cocoa. And of course, because this is the sequence, you can also model that there is a sequence of values down here, which makes observable like this one of those types that are a little bit hard to use, because when you see an observable, you don't really know what's going on there. You need to really stick to conventions or use one of many additional variants of observables, like completable or single or maybe, to express the logic better. But still, at least you don't have to wrap containers like containers. But this is not only the only choice. For example, I've seen in various future libraries, I've seen that a lot of them is using something called future result. They may call it just future, but basically it's like a future result, which means that the future is not only saying that something will be executed asynchronously, but also is having like those internal enum state that says that something has errored or completed without an error. And also the 4th solution, which is only like to get better understanding of things, because it's not coming at least anytime soon to Swift, is to check something called higher kinded types. And higher kinded types are also another concept from Haskell, which makes it possible to write the logic of transformers, let's say directly. Just write types that know that are containing some other containers, basically. There is some work, not much of them, with trying to implement some library about higher kind types in Swift. The one that I really enjoyed recently was, again, by Yasuhiro Inami. He has this higher kind Swift library on GitHub. And that's all. Let me just quickly recap. I think types are pretty cool to use to express the logic better. I think it makes for a declarative API, which is way better than the one that we are usually working with, for example, based on completion handlers. If you do have nested types, there are those 3 ways. You can always provide transformers, but transformers are not sustainable in a way that they won't go that many layers deep easily. So it's always a good idea to, if you see a long signature, treat it as a code smell and think about transforming your data model, or thinking about, is this information really needed in this particular place? Should it be really passed somewhere down the road? If you're writing transformers, there's 2 ways. One is this protocol-based RASURE way, and the other one that is about making those protocols, and the other one is about making constraints on methods. And if you have too many transformers, think about the observable, think about what you use, and if it fails, you can always look at what a reviewer has done and think of, and maybe try to generate some of them. Okay, and with that, thank you very much for listening. One thing, this talk was basically, it ought to be live coding, but when I started coding, it was just a little bit too much code. So the project that is having all the source code that I was showing and variants of services using different kinds of these APIs on those steps will be available at GitHub, and I will just post it, okay? Because I have all this code already available. It's just, well, it wasn't just that quick to write that. So thanks much, and if there are any questions, I'm happy to take them. I'll give you a microphone, but I don't.
Do you really think that, because all of the chaining that you're doing here, or all of the types basically express what's happening down below in the system. And do you think that on the top layer, is it really better to know about everything that happens in the system, or should you just try to split it in a couple of interfaces, like down below, that only know about a part of the transformation that's going on and forget about what's going on in the rest, like based on what you have presented?
Okay, so I totally agree that you do not need to pass all the information. Usually, as we started with the signature, it was like way too long. It was way longer than it was at the end, so we could just go basically doing what you said. Of course, we could also just change it in a way that we could provide some other layers that are just handling some parts of, and just like shrinking the signatures step by step. So yeah, it's basically, maybe in your app, you will never get to the situation when you really like need it. It also depends on the API that you're using. Maybe the API that you're using is like a little bit more modern than the usual Cocoa networking API, and some of the situations are already handled by the library, which will be awesome as well. So definitely, I don't think like that putting types into the signature is a good solution. So you should try to stick to as short signature as you can. But if there is a logic that really it requires you to pass things, I think it's still good to know how to make it a little bit more manageable. Yeah.
So have you ever encountered that situation exact in your code base actually, or is it like a fun?
This one?
Yeah.
Yeah. I mean, this was basically like this talk. As I said, it's born out of the challenges that I had when I was learning the Firebase API. I've never used Firebase before, and I had to use Firebase Cloud Storage. And Firebase Cloud Storage is basically about registering callbacks, and then you get the update every time that the value changes. And those callbacks are in this Cocoa format that you can have both optional value and optional error. And I was just trying to work with that in the service, and I was just thinking about, okay, so the service will do like those 3 steps, very simple steps. I mean, the whole service was like 20 lines of code, right? Maybe 30. And I was like, how come this is becoming so complicated? How come this is like so difficult to work with? Why do I have to like write those maps and maps and maps? And then that's why I started to look at this pattern of transformers. Yeah.
Thanks very much.
Any other questions? Okay, if not, so thank you very much, and enjoy your break.